Hi, my name is Ashutosh Yadav and I am the student of the BSc on the Data Science and Artificial Intelligence online degree program at IIT Guwahati. Today I am presenting my project term 1 project course code DA377 trimester 7. My project is called as a leafAI AI. It is a plant disease detection system powered by deep learning. The idea is simple. Farmer can take picture or photo of the diseased leaf and upload it, and system will instantly tell them what the disease it is. So why does this matter? The plant disease are massive problem globally. They cause an estimated $220 billion in the crop loss every year, and about 80% of farmers, especially in the developing country, don't have access of the plant pathologist who can diagnose this disease. The key challenge is timing. If you detect the disease early, you can treat it and save it the crop. But if you wait even the few days, the damage becomes irreversible and can spread to the entire field. So our solution is and AI-powered tools that can instantly identify the plant disease from the simple photo, and it is designed to accessible to any farmer. The only is need the mobile phones with the latest update and the cameras. For the project, I have focused on the two crops, potato and tomato, covering the total 13 disease categorically. Let me briefly go through the tools I used. Python 3.10 was my primarily programming language. For the deep learning. I used TensorFlow and the Keras to build and train the convolutional neural network. The backend API is built with the fast API, and it is the modern asynchronous Python web framework that handle the image and upload the run model interface. The frontend is with the React 18 applications using the Material UI for the user interface component, and think like a drag and drop image upload and the result display. I use the Docker with the Docker Compose for the containerized deployment, so the entire app can start it with a single command. For the image processing, I have used the NumPy and Pillow, and all the model training was done in the Jupyter Notebook running on my personal laptop, having the specification of NVIDIA RTX 3050 GPU with the CUDA 11.2 version. For the training dataset, I have used the Plant Village dataset. It is a publicly available benchmark dataset from the Kaggle containing over the 15,400 the label image of healthy and the disease plant. For my project, I have used the subset of potatoes having three class early blight, late blight, and the healthy with the total of 2,152 image and tomato having the 10 classes including the bacterial spot, early blight, late blight, leaf mold, and other with the total of 16,000 images. One of the challenge with this dataset is the class imbalance. For example, tomato dataset having yellow leaf curl virus having the more than the 5,000 image, while the mosaic virus only have the 373 classes the only. So this is affect the model ability to learn the minority classes. I split the data using the stratified sampling, 80% for the training, 10% for the validation, and 10% for the testing. All images were resized to 256 by 256 pixel, and the normalized to 0 to 1 range. Let me walk through the key part of the code. Let me cover the three area. First is the CNN model, second is data augmentation, and third one is a fast API backend. Through the actual code, I will open the training notebook and explain the step-by-step process, then briefly show the how fast API backend will work. So the very first thing we have done is
is to detect the GPU. I am using TensorFlow 2.10 with the NVIDIA 30x 30 3050 laptop GPU. This is cell configuration with the CUDA library. So as you can see that the GPU is detected. This is an important thing because the training is running on the GPU is roughly 10 to 20 time faster than the CPU training. Uh, and next the batch size is 32 and image size is 56. So I have defined this key parameter as a batch size is a 32, which is a common choice for the image and image classification, and resized to the 256 by the 256 with the three color channel. That is a standard RGB channels, and the model train on the 50 epoch means see the entire training set of 50 times. And after that we have done the data set loading from the image data set from directory cells where our all data is just located in the plant village directory. Then I have a load the data sets using the keras image data set from the directory utility. It read directly from the plant village folder where each folder name became the label class automatically. The output is a tells us as a 2152 images belong to the three classes of the potato. I- the image are automatically shuffled and batch into the 32 group. This is a very convenient API. It handle the all file reading and the label assignment for us. Here I have a plot a grid sample of image with the label so can visually briefly the data and look the correct. You can see that the clear example of early blight, late blight, and the healthy green patches. This is always good sanity check before the training, so I have printed that. The data set is then split into the three partition of 80% for the training, 10% for the validation, and 10% for the testing. And what the model learned from. Now the core of the project is a CNN model. It's a built on the TF Keras sequence dot sequential, which means the layer are stack one after one another. The first layer is a resize and rescale. Rescale. These are backed into the model itself, so the same processing run and automatically during the interface. Pixel value are normalized to 0 to 255 down to 0 to 1 range. S- Next come to the data argumentation. Uh, Random flip and random orientation, these apply the random transformation during the training to increase the variety and reduce the overfitting. Importantly, they are only active during the training set, so there is no nothing to do in the prediction. So then we have a convolutional block multiple conventional 2D layer with the 32 and the 64 filter using 3 by 3 kernels followed by max pooling of 2D. This layer extract features as texture and the pattern from the leaf image. Finally, Finally, the features are flattened into passes through the dense layer with the 64 neurons and the ReLU activation, then the softmax output layer with the three neurons, one for each classes, and softmax give the probability of distribution across the three diseases. The model is a trained by calling the model fit function with the training and validation data. If you look at our last epoch, which means the 50 epoch, you can see that. The training accuracy is a 99.88 and the validation accuracy is a 98.44%. The training loss is extremely low at the 0.66 only, 0.006 only. This tell is the model has learned parameter very well and the small gap between the training and the validation accuracy means the overfitting is a minimal and the our augmentation layer does their job. The result is a 98.66 accuracy, which confirms that the model generalized well to the new image and it didn't just memorize the training data. These these plots show the training versus validation accuracy and the training versus the validation loss at 50 epoch. On the left, you can see that the both accuracy curve and raise quickly and converge into 98 to 99%, which is a great. On the right, both loss curve drop smoothly. That fact that the training and validation curve is still closer to the together is a good sign. It means the model is not just overfitting. Finally, I have tested the model on the single image from the test set, and the actual level is a potato late blight, and then the model prediction is also potato late blight. It is a correct classifications. It is essential what happened into the deploy application. The user upload an image and the model return the predicted disease. So our potato model have 97.2% test accuracy on the three classes, and the tomato model is 89.66% on the 10 classes. The lower tomato model accuracy is due to the visual overlap between the diseases and the class imbalance, as we can see, and the data argumentation improved the accuracy by the 12 to 50 percentage. So
Yeah, hello everyone. Let me show you the live demo of this project. So here I have started main backend main file, and here I have started restarted the frontend file, which is just running on the 3000 port, and backend is running on 8000 port. So from backend, let me show you from first backend file. Uh, Predict potato. So we have a potato image. So let's upload it. So after uploading, we can see that there is a 99% accuracy, that is a early blight image. So same thing we can do from the front end, and we'll check. So I'm uploading the again the potato image, and this is showing the same 99.8% the accuracy. So let us check for the potato image. No, sorry, tomato image. So for tomato image, we can see that it's showing 100% early blight from here. So our model is a much accurate, but there is a lot of issue with this model. I can say that in the potato, it's showing the 100% early blight, which is a totally wrong. Fuck. Yeah, hello everyone. So let me show the live demo of this project. So here I've started the backend file main.py and it is started on the 8000 port. And here we have started the front end file front end which is already running in my browser. To minimize this video, I have already started this ports. So let us test it. So from here, let's predict first from here. So for the potato, we have some downloaded image from the internet, and let's check if it is predicting correct or not. So I am uploading the potato image. Yes, we can see that there is a 99% accuracy. It's a predicting that it's a early blight. Let's check from the here from the front end. So from the front end, we have uploaded the image, and it's showing 98.8. It is the same, 98.7. Seven. Is it 100% same as actually from the front end and back end? So let us check for the tomato image. So for the tomato image, we have uploaded a file. Yeah, it's showing early blight with the 92.4%. So the both image is for the early blight. So let us check one more image. For the potato, we will check. We have some sample image. Yeah, it's showing the healthy image. Let's check it's if model predict correct or not for the healthy image. Yeah, we can say that our model is predicting 100% healthy image. So that's all from my project side. So I from this project I have learned a lot of things from start to end. Thanks for watching this video. Hope you have liked.
To wrap up, this project taught me a lot. I learned how to design and train a CNN from scratch and build a full stack web application and deploy to the Docker. If I continue this project, I would add the early stop and the modern checkpoint and callback to prevent the overfitting, and try transfer learning with the trained model like a ResNet and EffectNet, which could be significantly boost my the tomato accuracy, and build a mobile application using the TensorFlow Lite and the offline field use, and extend to the more croppage like rice, wheat, and corn. The 97% of the accuracy so that the concept work well, and the 87.6% tomato accuracy so that there is room to improve, especially the transfer learning and the better handling class imbalance. That's all from my side. Thank you for watching my video.